Hey guys, welcome back. Houston Math Prep here. In this video, we're going to look at some examples of identifying polynomial end behavior from a polynomial equation. So for each of the following equations shown here, we're going to determine the degree and the lead coefficient. We'll then use that information to sketch a simple end behavior diagram. So let's begin here with g of x. Remember that the degree is the highest power of x that is found in the polynomial. So when I look at my three terms, I have x to the fourth, x squared, and no x's. So my lead term is 5x to the fourth. The degree is that highest power of x. So in this case, my degree is 4. And the lead coefficient is your constant multiplier in the front of that term. So in this case, 5. Now those two pieces of information together allow us to know the end behavior of g of x. With a positive lead coefficient, that tells me that the behavior to the on the right is up. With degree 4, I know that even polynomials have exactly the same end behavior on both sides, so my left-hand end behavior must also be up. So my end behavior for g of x is up, up. Moving over to our y equals equation here, I'm going to do the same thing. I'm going to look first at all my powers of x and identify the largest one. I have x cubed, x squared, x to the first power, and a constant. So my lead term is the term with the highest power of x, in this case, negative 2x cubed. So my degree is that highest power, or 3, and my lead coefficient is the constant multiplier, negative 2. So with a negative lead coefficient, that tells me that on the right, my arrow is pointing down. Since I have an odd degree, I know that odd degree polynomials have opposite end behavior. So on the left-hand side, I should have up. So my end behavior is up, down for this y equals polynomial. All right, continuing in that same way, looking over here at p of x. Once again, checking over all my powers of x, I find that my lead term here is x to the fifth. That power is my degree, so I have degree 5. And when I don't see a multiplier, I know that that is a coefficient of 1. So with a positive lead coefficient, that tells me the end behavior to the right is up. And with an odd degree polynomial, I should have opposite end behavior on the right. So I'm going to have down. So down, up, from left to right. And last but not least on this screen, k of x. Checking all my powers of x, I do see that this polynomial is not written in standard form, so my lead term is actually down here at the end. So my highest power of x, therefore my degree is 6, and my lead coefficient is my constant multiplier for that one, which would be negative 2. With a lead coefficient of negative 2, that means my end behavior on the right is down, and with an even degree polynomial, I know that I should have exactly the same over on the left, so also down. Okay, so that's how we find end behavior from an equation. Let's now try to do the opposite. Let's say that we have polynomial graphs that are shown to us. We're going to look only at the end behavior and try to determine if the degree is even or odd, and if the lead coefficient is positive or negative. So let's start over here in the top left. Looking at my end behavior, I have down on the left and up on the right. So since those are opposite, I know that I have odd degree. And for lead coefficient, look at what's going on at the right. So since we're going up, that must mean we have a positive lead coefficient. So this polynomial would have a positive lead coefficient with an odd degree. Going to the one just below that, again, checking out my end behavior, I have up on the left and up on the right. Since those are exactly the same, I must have an even degree. And using the behavior on the right, since it is going up, I would have a positive lead coefficient. Moving back up here to the top, checking out the end behavior here, I have down on the left and down on the right. Because those are exactly the same, I must have an even degree polynomial. And checking out the end behavior on the right to know about my lead coefficient, since that is pointing down, I must have a negative lead coefficient. And last but not least, our one over here in the bottom corner, checking out our end behavior, we have up on the left and down on the right. Since those are opposite in nature, we must have an odd degree polynomial. And using our behavior to the right to know about our lead coefficient, since that is pointing down, we must have a negative lead coefficient. Okay guys, that does it for this video on polynomial end behavior. We'll catch you in a future one.